So we're going to have a look at how surface area affects the rate of a chemical reaction. So let's think first of all about the reaction of a solid. So I've drawn a cube, and that represents a cube of marble chip. A marble chip reacts with hydrochloric acid. So I'm going to put my marble chip in a beaker like this, and then I'm going to add from a bottle some hydrochloric acid. Now the hydrochloric acid is a solution, so what's going to happen is I'm going to fill up my beaker with hydrochloric acid, and there's going to be loads and loads of hydrochloric acid particles. So these hydrochloric acid particles that you can see here can hit the surface of the marble chip, and a reaction can take place. So the particles can collide with each other. So the marble chip is made of particles, and the hydrochloric acid hits the surface of the marble chip, and we can have a successful collision and a reaction can take place. Let's have a look at what happens if we break that piece of marble chip into some smaller cubes. And I'm going to break it into 8 smaller cubes. So I'm taking the same volume, the same mass of calcium carbonate, but I'm breaking it up into 8 smaller cubes. And I'm going to put those smaller cubes, those 8 smaller cubes, which is the same amount, the same volume, the same mass of marble chip, and I'm going to put them in a beaker, or only just going to fit that one in, and I'm going to put them in a beaker with hydrochloric acid. So we're going to have lots of hydrochloric acid particles in here. Now this time something different is going to happen to the rate of the chemical reaction, because in this example only the surface of the cube, the particles on the surface of the cube, could react. In this example we've got much greater area of exposed surface where the particles can collide and a reaction can take place. So what we would see is this reaction would be slow, and that reaction would be fast. So what's actually happened here? Well, if we have a look at our large piece of marble chip, so the surface area of our marble chip is the total area of all 6 sides of our cube. So don't forget that this is a cube, so there's 3 surfaces that we can't see here, underneath, on the back and on the side here. So there's 6 surfaces. So this is a large, big piece of marble chip. It has got a small surface area. So there's an inverse relationship here, a backwards relationship between the size of the piece of marble chip and the surface area. Let's have a look at this one over here. So when we broke up our marble chip into 8 smaller pieces, we didn't change the amount of marble chip. We have the same amount of marble chip in total, but we've broken it into smaller pieces, and if we look at the surface area of all 8 of these combined, it's much larger. Now there's a way we could increase the surface area even more, and that would be to take our marble chip and grind it up into a powder. Then the surface area would be absolutely huge. Don't forget, we've still got all of our hydrochloric acid particles reacting in here. So, why is this important? Well, there's our first piece of information. So if we have a larger surface area, then we have more exposed particles. And as we've done every time when we've been looking at rates of reaction, if we increase the number of particles available to react, we increase the chance of a successful collision and therefore the rate of a chemical reaction. Okay, so we now need to be able to think about how we can do some calculations involving surface area and volumes. I'll leave that whole page there for one moment if you want to pause the video and take any extra notes. So let's have a look now at surface area to volume ratio. Don't be panicked by ratios, easier than you think it is. So let's have a look at our large marble chip again. Here's our large marble chip, and I'm going to say that the sides of our cube are 2 centimeters each. So we're going to work out the area of one side first of all, and that's going to be the length multiplied by, sorry, the height multiplied by the width of the side. So 2 centimeters multiplied by 2 centimeters equals 4 squared centimeters. There are 6 sides on this cube, so the surface area of 6 sides is equal to 4 centimeters squared multiplied by 6, and that is 24 centimeters squared. So we've worked out the surface area. We now need to work out the volume. The volume of a cube is going to be 2 multiplied by 2 multiplied by 2. Cubic centimeters. So we then want to work out the surface area, which I'm abbreviating to S dot A dot, to volume ratio. We know that the surface area is this, and we know that the volume is this. So I'm going to do this calculation, that divided by that, the surface area divided by the volume, which gives me 3. I could leave that as my ratio if I wanted to, but my actual ratio in this case is 3 to 1. Let's do the same thing for our 8 smaller cubes. So remember that we haven't changed the total volume or total mass of marble chip. All we've done is to break our big marble chip into 8 cubes, and we've massively increased the surface area. So if our large cube was 2 centimeters by 2 centimeters by 2 centimeters, each of these 8 cubes is going to be 1 centimeter by 1 centimeter by 1 centimeter, and there's 8 of them. That's going to become important in a minute. So let's have a look at the area of one side for 1 cube. I'm just doing this for 1 cube. That's going to be that. Let's have a look at the surface area of 6 sides for my 1 cube again, and that's 1 centimeter squared. I've worked out the area of one side, and there are 6 sides, so there's the surface area of 6 sides. But don't forget there's 8 cubes, so we've got now 6 centimeters squared, apologize about that, multiplied by 8, which gives us 48 centimeters squared. So if we have a look back at what we did in our last example, we had a surface area of 24 centimeters squared. We've now got, sorry about that writing there, we've now got a surface area of 48 centimeters squared in our 8 cubes. So we've doubled the surface area. Let's have a look and do the same thing with volume. So we've done this part. The volume of 1 cube is going to be calculated by this. And then the volume of 8 cubes is going to be my volume of 1 cube multiplied by 8, which is 8 cubic centimeters. And if we have a look, that is indeed the same volume as we had for the previous example. So surface area to volume ratio, remember SA I'm abbreviating for surface area. Surface area to volume ratio, this time it's 48 squared centimeters to 8 cubic centimeters. So I do my calculation by this, and therefore this is my surface area to volume ratio. I'll zoom out to the whole page, so if you want to take any notes you can. Almost there actually. Thank you very much.